Hey guys, I want to clarify systems that have different solutions or special solutions. So this is on page 145 of your book. Um, and so right here where it says a system of linear equations can have one solution, no solution, or infinitely many. We have typically only seen this, okay, where you have two lines. You have one line, I don't know, I could call it f of x, and then you have another line, g of x, okay? And we're trying to find where f of x is equal to g of x. So this is where they intersect. Okay, and so that point would be this point here. And if I had to estimate it, maybe negative 1, 1, something like that. And you're going to find something like this whenever you have different slopes. So that's another thing I'm going to write underneath here, the notes. Is it f of x is going to be equal to g of x, and then the slopes are going to be the same. Different. Slopes are different, and I'm just going to randomly make up one, and I'm going to put it in slope-intercept form. So y equals 2x plus 3, and y equals negative 4x minus 8. Okay, so the slopes are different. The second type of solution that you're going to see is no solution. Okay, and so you can see here, again, I'll call it f of x, and then the other one, g of x. Do they ever intersect? And the answer is no, because the lines are parallel. And so what that means is that these ones don't intersect. These do not intersect. And so these systems actually have the same slope. So they have the same slope, but you're going to see that they're going to have different y-intercepts. And then if I were to just randomly make up a couple, I would say y equals, let's say, 1/2 x plus 2, and y equals 1/2 x minus 8. Okay. The last type of system you're going to see is called the infinitely many solutions. And really, you're only going to see one line. Okay. And so the red line, f of x, and the blue line, g of x, they're right on top of each other. Every single point on one of the lines is a point on the other line. Okay, so that's why it's infinitely many. And so what you'll see on these ones is that the lines are exactly the same. You'll only see one line. And if you were looking at the equations, they would have the same slope and the same y-intercept. Okay. And then if I randomly make one up, I'd say like y equals 2x plus 4 and y equals 2x plus 4. Typically, they won't give them to you like this. They might show them to you in standard form, like x plus y equals 2 and 4x plus 4y equals 8. If you could see in this pair of systems that this top equation right here can be multiplied by some number to get you the bottom number, and in this case it's going to be 4, right, times 4, then that means that it's going to be a dependent system where you're only going to see one line. Okay, so what I want to do is practice mathematically how to solve these. Okay, so you're not looking at a graph, you're looking at the equations. So if I go to solve, I'm going to go ahead and use substitution. Plug that one in here, and I get 3x minus 7 equals 3x plus 4. And what I notice is that I see the x's are on the same side. So I get negative 7 equals 4, which is a false statement. And this one is no solution. Okay, so this is my answer, and just graphically what that's going to look like is just a pair of parallel lines. Okay.